Rugrats is movie, Busta Rhymes, and
Anyways.
Boys to Men.
Was it really?
Yeah.
I like Busta Rhymes.
Well, see,
I like Busta Rhymes a lot.
yeah, so we rewatched it. I knew that.
Very interesting. I never
Did
knew
you
that.
watch the Rugrats movie?
No, I might actually watch it now because Busta Rhymes is one of the voices.
I watched it.
Yeah, but Snoop Dogg is one of the greatest rappers ever. I love that guy.
Who's your favorite rapper?
Because my iPod's like 75% rap, so you know. Prejudice towards rap, you know, bias. Pretty darn good, actually. Good stuff.
Oh, no, I gotta put it in.
Rejected.
Make us wait for recording.
Oh, it's recording? Oh my gosh! I like Busta Rhymes. So like we were saying, Busta Rhymes. All right.
Who's your favorite rapper of all time?
Oh, probably Chuck D, I would say.
Ooh.
Public Enemy. Greatest band ever, something. Without a doubt. But anyway, I digress. Okay.
My favorite rapper was Pete Wade.
Absolutely. Hey, I'm in the top 10. Most definitely. Did a couple of tours. Okay. But that's a long story. I'll tell you that later. All right. So, and we're back from commercial. Okay. Prince Ray was a rapper. Yes, that was a couple of years ago.
Yes, it's on TV.
A couple of decades ago. All right. All right. First things first. Let's take the derivative. And that would be 8x to the third minus 32x, and we can set that equal to 0, but I'll tell you what, let's go ahead and factor it while we're here. What could you take out of this, right?
Yes.
Okay, hey, anytime you take something out, it makes it easier. X, what else?
A.
Okay, how about 8, sure. Okay, 8x, and that's going to leave us with x squared minus 8 goes into 32 times, how many times? Wait a minute. 8 goes into 32, 4, oh.
A difference of 2 squares.
Oh, nice. You're welcome. All right. I built this problem from the ground up. All right. And it works out so nice for us. Okay. And when we mean, I can give you x squared minus 7. That's going to be a pain. All right. But I'm not. I'm nice. So we have several answers here. We have 8 times blank equals 0. 8 times 0 equals 0. And
Plus or minus?
oh, plus or minus this time, isn't it? Because of the even power, right? Okay, so we have 3 critical numbers, right? Okay, negative 2, 0, 2, put them in order, and
Just write plus or minus.
okay.
No.
Yeah, not in the graph.
But for your answer.
For there, yes. Yeah. Of course, in the graph, you have to space them out. So, if you plug in some sample points, such as
Negative 1,000.
negative 1,000. Okay.
Negative 1.
You know, there are infinite numbers between negative 2 and 0.
I like 1. Negative 1.
But there's only one integer, so let's take the integer, right? Sure. And we're going to pick 1.
Yeah,
So half followed 1/2 or 1/4. And 1,000. Okay, you got some nice symmetry there. Very nice. Okay, now let's take these and plug them in. Tell you what, let me show you today how mathematicians would do it, and I think a lot of you as honor students will enjoy this as well, okay? Otherwise, you can do the way we did before. As a mathematician, I think we think like this. We don't think about plugging the negative 1,000 in for all the x's. We think about each group at a time instead, okay? So look at the 8x only, right? If I do negative 1,000 times 8x, what do I get?
Negative.
Okay, negative. Okay, let's get this for now. Look at the 8x again. Negative 1 times 8x is still negative. It still hasn't changed. That's because we haven't gotten to 8x's root yet. Now I'm going to transgress the root and go over here. 1 times 8.
Positive.
Ah, it changed around its root. The only time you can change is around your own root. Then 1,000 times 8. So your mindset is kind of, you just multiply by 8, multiply by 8. You're in the same mindset all the way through instead of having to change back and forth. Okay? I like that way better. If you want to do it that way, you can do it. Okay? Then I reset back to the beginning, and now I just focus on this parentheses. So, negative 1,000 squared,
Positive.
gigantic number minus 4,
Positive.
positive. Okay? Negative 1 squared,
Negative.
okay, that's going to be 1 minus 4. Ooh, I just got to change. You know why? I just went around one of the roots of that parentheses, right? There's the change. Okay? Think it'll change here?
Yeah.
Wait a minute.
Yeah. No.
0 is not the root of this parentheses, so I don't think it'll change right here. Watch this. What's 1 squared minus 4?
Negative.
It's negative, right? So that parentheses, I mean, doesn't change, right? Okay, just the parentheses, okay? And then look at the parentheses to parentheses. 1,000 squared minus 4?
Positive.
What do you know? How about that? Okay? So we get a negative, a positive, a negative, and a positive.
Yay.
Wow, I'm so surprised that I got that. I can't believe it.
I'm actually doing.
Okay, well, okay, you might be surprised, but let me clue you in. You'll be like, oh yeah.
It's
X to the fourth. X to the fourth is always a what?
Parabola.
Parabola.
But it's.
But then if you throw the squared into it, it bends it. There it is. And it's down, up, down, up. Says right
Just like
here.
that.
Decrease, increase, decrease, increase. Okay? And you don't have to hit the points in the right place because this is not really the x-axis here. This is just a number line. Okay? So it's a W shape. That's all we need. All right. Critical numbers. 0 and plus minus 2. You do not need a sign change to make it a critical number. You just need a neutral derivative. But actually, these were all sign changes. Now, you do need a sign change to get these extreme right here. Okay? So, relative minimum. The relative, or the relative minimum, because there are going to be 2 of them. Aren't there 2 values?
Yeah.
Okay? There's a value at -2, there's a value at +2. So let's put +2, comma, I don't know, and -2, comma, I don't know. How do I know? To the original function, the only thing you use that for in mathematics is to find a y coordinate.
But don't you
That's
just
it.
have to plug 2 in?
Okay.
Because because they're.
Very nice, because the even powers,
It's even function.
you will get, very nice, okay, you know this stuff, don't you? Tyler, one of the best calculus students in the school.
I
Okay.
mean.
I mean, Steve, I have to use names on YouTube. Yes, Steve Chiavo, one of the best. Okay, so take 2, put it into the original function, right? Let's go like to the bottom corner of the page where you have some room there. And let's plug this in. All right, and when you plug that in, well, let's see, I got 2. Actually, it's not too bad. 2 to the 4th is not too big. But if you want to help yourself out, I might factor some stuff out. Okay? Matter of fact, 2 to the 4th, 2 squared, what would you take out here?
2 to the 4th.
You could take out, if you're really creative, you could take out 2 to the 4th, right? Okay? And otherwise, you could just put, okay, thank you very much for your response.
Bye.
Okay, Stephanie, good time. Okay, so take out, from these right here, at least take out 2 squared. Can you see these 2 right here? Okay, couldn't you at least take out a 2 squared? And actually, from the 2 and the 16, from 2 and 16, you could at least take out a 2, or if you're really creative, you can take out even more. Because technically, isn't that actually 2 to the 5th? And isn't that actually 2 to the 6th? Because that's 2 to the 4th right there. So you can be really creative and take out a 2 to the 5th out of everything, make it really easy, okay? At least take out this much, though. At least take out something. Because it'll make it so much easier. Okay, now, 2 out of 2. If I take 2 out of 2, I still have 1, and 2 squared out of 2 to the 4th is?
Thank you.
2 squared or 4. If I take 2 out of 16, that leaves us with 8, and 2 squared out of 2 squared, which is 1. And already I made the problem easier. And if you take out that 2 to the 5th, you make it really easy. Okay? It just makes it so much faster to take stuff out. Okay? And like I said, a year from now in calculus, we'll still be doing the same stuff, right? Okay? It's this stuff right here. Factor the numbers out, do a derivative test. Okay? It's more complex problem. So what's 2 times 2 squared? That would be something 8. Okay? And then 2 squared is 4 minus 8 is?
-4.
Okay? Now, no matter how you hatch this egg, you get 8 times -4. Okay? And you get a grand total of
-32.
-32. So feel free to factor out as little or as much as you want, but the more you factor out, the easier you make the problem for yourself. Okay? And then you can plug in -2, even power, you get the exact same thing.
Again to the maximum.
Guaranteed. Huh?
You have to do again to the maximum.
No, maximum is easy. Where is the only peak in this problem? At 0. Take 0, plug it back in, that's 0.
Hey, 0.
0, what is 0 is 0. Oh, so actually, it's
That's on
peaking
the-
at the origin, it's bouncing off the origin from
So
underneath.
I drawings in it.
Yeah, so no, this is not the x-axis. This is just a sketch.
It's a perfect oscillation.
So basically, it's property factor. Okay? Yes. Okay? Now, the absolute minimum. What is the absolute lowest place? You know what?
32.
We've got a tie. We've got a tie between both points. You have to list both points, because these are still coordinates. So we're gonna list both points, this one and that one. And if it's tie, list them both. If one is clearly lower, if one has a lower y coordinate, that's the winner. If they both have the same y coordinate, it's a tie.
What's the 0, 0, the absolute minimum?
That's the absolute, oh wait, I got these things written so small here.
That's the relative max.
Yes, that is the relative max. Squeezing these words too tightly here because my answers. Okay, yes, that's relative max. We are now on the absolute minimum. And then the absolute maximum, what's that?
0, 0.
That 0, 0 is pretty high.
But it's not.